Hi class. So let's look at the next topic here, which is on remainder theorem. Okay, so what this is looking at is if you are looking at a polynomial px and you're dividing it um, by q minus, x minus a, um, how it sort of resembles what we would do in long division. Okay, so let's look at this first one here. Okay, so we're doing the division. So we got x4. Now, when you write this out, like in this question here, it's written in the proper order, so that's descending powers. But if it's not written in that descending powers, you got to make sure that you switch it that way. Okay, and then like I said, it's sort of long division here, so x minus 1. Okay, so we're multiplying by x minus 1. So what you want, so exactly like long division, what you want to do is you want to get rid of first that x to the power 4. So we have x minus 1, so we're going to multiply this by x cubed. Okay, so that gives us x4. So now you're multiplying x minus 1 by x cubed. So that gives you x4 minus x cubed. Okay, and then you can subtract that. So again, just like long division. So you got negative 2x cubed minus x cubed, which is, negative 2x cubed minus negative x cubed. So there's two negatives there. So you get negative x cubed plus x squared. Okay, so now we'll multiply this by minus x squared. So that gives us negative x cubed plus x squared. Okay, and now that'll all go to 0, so we can drop the next two down. So that gives us negative 3x plus 4. So we can multiply this by minus 3. And so that gives us negative 3x plus 3. And so what we get here is a remainder of 1. Okay, so now what we want to do is we want to present our final answer. So the way we present the answer is just what it says above here. So qx would be the quotient, okay, which is what you get on the top here. So this would be qx, and then this is your remainder over here, 1, and then you put that over x minus a. Okay, so the way this is going to look, your answer is going to be then x cubed minus x squared minus 3, and then plus, because it was a positive 1, plus 1 over x minus 1. Okay, because that's what we're dividing by. And so there's your final answer. And then because you have that x minus 1, you should add in here that x can't equal 1. Okay, and so this would be your final answer. So that's a fairly lengthy way to do it there. But if you're comfortable with doing it that way, you can always do it that way. I'll show you another method, which is called synthetic division. So same idea. We want to divide and get an answer. So I'll set this up a little bit differently. Okay, so I'll write this out here. So we got, so again, same as before. Make sure you have this in descending order if it's not written that way in the question. Okay, so you've got x cubed and 7x squared and minus 3x plus 4. Okay, so there's what we're looking at. Okay, so now what you do is you make this table. Okay, so we have x, and we've got minus 2. Okay, so what you do is you look at you look at sort of um, the, uh, the coefficients here. Okay, so if you start with the x cubed, we've got a coefficient. Oops, I'll use a different color here. We've got a coefficient of 1. And so that 1 just comes down. And then we've got the next one here. We've got a coefficient of 7. And then we've got the minus 2. So that's a minus, or sorry, this should be a minus here. So that's a minus negative 2, so that's going to be a 9. And then we have a coefficient of negative 3. And that's going to be minus 18, because 9 times negative 2. And so that's going to be, so negative 3 minus negative 18, so that'll be 15. And then times negative 2, that's going to be negative 30. And then 4 minus negative 30 is going to give you 34, which is going to be your remainder. So what this looks like then is your answer here is going to be x squared plus 9x plus 15 with remainder 34. Okay, so that's kind of a faster way. You might find that a little bit confusing, so let me just kind of go through it again. So it all has to do with the coefficients. Okay, so this is, so what you have here is the minus 2, and that's a negative because of the subtraction. And then you've got the x here. Okay, so again, what I'm doing is I'm looking at the coefficient of x cubed, which is a 1. And so that just drops down, and then the next one is a 7. And then where I'm getting the minus 2 from is because it's 1 times negative 2. Drops down as a 9. Then 9 times negative 2 is negative 18, subtracted from the negative 3, which gives you the 15. And then 15 times negative 2 gives you the negative 30. And then you subtract that from the 4. And so if you understand this method, you can use synthetic division. If this is more confusing, then use the long division. So had you done the long division, you would have got the same answer. Okay, so let's do another example here. So when you kind of get this method, you should be able to do it a little bit faster. I can just drop these down right away if I want. Here's kind of a variation. So this has a coefficient of 1. This is negative 4, negative 7, and 10. Okay, and so same as before. We're dividing by x minus 2. Okay, so we start with the 1, okay, and then that's going to be multiplied by negative 2. Okay, so we got negative 4 minus negative 2, so that gives you negative 2. And that's going to be multiplied by negative 2, so that gives you 4. Okay, so negative 7 minus 4 is going to give you negative 11. And then that multiplied by negative 2 is going to give you 22. And then 10 minus 22 gives you negative 12. Okay, so that's the remainder. Now there's another way you can get the remainder as well, if that's all you're looking to do, and that's called using the remainder theorem. Okay, which is basically saying that the polynomial that you're dividing by a binomial x minus a, you can determine the remainder by substituting a into the polynomial. Okay, so that's basically what it says here. Okay, and they run you through an example here where you're taking x cubed minus 4x squared minus 7x plus 10. So this is your polynomial. And so suppose you're dividing it by x minus 2. The way you would determine the remainder is by substituting 2 into the polynomial. So notice it's x minus 2, but we're substituting 2. So what you see here is you're using the opposite sign. Okay, and then you put that in, and then you get negative 12 as your remainder. Okay, and that you would find the same remainder had you used either long division or synthetic division. Okay, so let's try this one here. And we'll close with this one. So here's your polynomial, x cubed minus 10x plus 6, and you're dividing by x plus 4. Okay, so what we're going to want to do here is we're going to want to find p of negative 4. Okay, so again, notice it's the opposite sign. It's x plus 4, so that's why we're using negative 4. So just sub that in. Okay, so you're going to get negative 4 cubed minus 10 times negative 4 plus 6, which is going to give you negative 64 plus 40 plus 6, which is going to give you negative 18. Okay, and so there's your remainder. Let's just do one more synthetic division just to show you that works out the same here. Okay, so if we're doing synthetic division, so here's your polynomial. So we got x cubed minus 10x plus 6. So this one, the reason why I want to go through this one is notice if you look at this polynomial, you notice that it's missing a square. Okay, so how would we write that out? So again, go by coefficients. So 1 for x cubed. Okay, there is no x squared, so your x squared slot would have a coefficient of 0. Okay, so that's important. Okay, so this 0 here is because you have no x squared. Okay, and then you've got negative 10 as your x, and then you have your 6 as your constant. Okay, so this one here, because it's x plus 4, you get a plus 4 here. So this is your what you're going to be subtracting by, and then this is your x. So again, just same idea, you just drop the numbers down. So 1 times positive 4, and then 0 minus 4. Okay, and then negative 4 times positive 4, and then negative 10 minus negative 16, and then 6 times positive 4, and then 6 minus 24, and that gives you negative 18. Okay, which is the same as before. All right, so I'll stop there. So that covers the section on the remainder theorem. Okay, and so you can do the questions that go with that now.